Okay, so let's continue part C, and so we have seen how to find PT leakage power from the transmitter to the receiver. Next question, how much power we get here? How much power is received? PR. Okay, so to do this, let's see the receiver part. Okay, so the receiver part start from the antenna. It comes to the oscillator, right? This is port number 2. Port number 3 is receiver side. So then the mixer, down converter mixer, as you can see in the diagram, there is a mixer here and a filter here. Then we have the receiver. This is our RX. This is our filter. This is down converter mixer. We'll discuss next time what's a mixer circuit, mixer components. So this is the receiver looks like, the receiver side. You start from the antenna, signal comes to the circulator, go to port 3 through a mixer, filter to the receiver side. How much power reach the receiver? That's the question. So how much power the antenna receives? A frequency of 10.1 gigahertz. The incoming frequency is 10.1 gigahertz. The transmitted one is 10, right? But the received is 10.1. How much power? You can see here the received power from the antenna is 0.1 milliwatt. Very small power. P antenna is 0.1 milliwatt. Okay. Okay, so the question is how much power reach at the receiver? PR, how much? So it's better always to convert milliwatt into dBm. Once you convert it, then it will be easy. It will be easy because it will be summation subtraction. Okay, so how much is 0.1 milliwatt into dBm? Convert that. dBm is always equal to, from our formula, tail log of the given power. Now in this case, the given power is 0.1 milliwatt from the antenna, okay, milliwatt, divided by, on the formula, 1 milliwatt, right? So let's see this one from our calculator. Minus 10, right? It is minus 10. So minus 10 dBm. That is the power here, minus 10 dBm. I convert this power picked by the antenna into dBm. Then the signal comes to the circulator. Now circulator guides from port 2, which is the antenna. It sends the received signal to port 3 because it is clockwise. So a signal comes here. Now in this case, how much power from the antenna? Minus 10 dBm. That is the signal we get from the antenna, signal power. Okay, this is part C where I'm calculating. Then circulator, how much loss? Is it 1 or 50? Is it insertion loss or is it isolation? It is insertion loss, only 1. Why? Because the signal is going in the correct direction. You see here, the antenna signal comes port 2. If it goes the correct direction, right direction, we subtract only insertion loss. So what is the insertion loss of this circulator? Only 1. Okay, now signal comes here. We have what? A mixer. So this mixer, very lossy device. We'll discuss about mixers next time. It's given this mixer has loss of 5 dB. Loss, how much? 5 dB. All the specifications of the device are given. So when signal passes through the mixer, what will happen? We lose some amount of power, 5 dB. And when you see here, the coupler brings this 10 gigahertz frequency from the transmitter side, bring this to the mixer. How much frequency comes here? 10 gigahertz. How much comes from the antenna side? 10.1 gigahertz. So this is a down converter mixer. Before go to the receiver, it's better to minimize the frequency. We'll discuss this next time. So the mixer is a frequency translator device. So it subtracts the RF frequency, 10.1, minus the local oscillator frequency, 10 gigahertz. So how much the frequency will be? Only 0.1 gigahertz. That's the mixer means. So here we have only frequency, the carrier of information is there. Okay. Then the receiver will demodulate, process your information and so on. But before that, carrier frequency, which comes from the antenna, is 10.1, which is very high frequency. So by using this mixer, we down convert the frequency from 10.1 to only 0.1, the carrier frequency. Then it's easy for the receiver to process, to demodulate, to correct errors and so on. So before the receiver circuit, we have what? A mixer. This mixer down convert the frequency from 10.1 to 0.1. So look here. So what's the disadvantage with mixer? It's too much loss, minus 5. Then there is a filter here. The filter also has loss of 1 dB. On the receiver side also we have a filter. So this filter also has loss of 1 dB. It's given on the equation. So we subtract how much? 1 for the loss. It will give us the received power, PR. You see, start from the antenna, minus 10. What's the next device? Circulator, minus 1. Next device, mixer, minus 5. Next device, filter, minus 1. You get PR. So how much is this? Minus 17. Sorry, minus 17 dBm will be the received PR. So PR, how much? minus 17 dBm reach the receiver. 17 dBm. How much frequency? Frequency will be only 0.1 gigahertz. We discuss this. Why? Because of what? Because of the mixer. Mixer mixes the RF with IF. Here the IF is 10 gigahertz. The RF is 10.1. Subtract the two, and we have intermediate frequency IF, which is only 0.1. Okay. Now finally, if the antenna receives a signal, comes here, is there a chance this signal go to the transmitter side? We don't need to go to we need all the signal to the receiver side because we are receiving information, right? But there is a leakage, unwanted leakage of this 10.1 gigahertz incoming signal go in the wrong circuit. This is the wrong circuit, transmitter side. How much that leakage? That's the next question. So what will be that leakage? Leakage from what? From the antenna to the transmitter. So how much signal comes from the antenna side? Minus 10 dB. Right? 0.1 converted into minus 10 dB. Then this port 2, if it goes to port 1, you see it's clockwise, but if you go in the wrong direction, how much we subtract? We subtract, in this case, it will be what? Isolation, 50 dB. So minus 50 dB. So how much power go in the wrong direction? Minus 60 dBm. Very small. If you convert minus 60 dBm into milliwatt, you can find very small amount of leakage. Leakage from where? From the antenna side to the transmitter side. Okay, so we continue next time.